Okay, hello everyone. Welcome to Concordia University's Force Space. Welcome back. It's great to have everyone here. Thank you for joining us for today's event. It's a whole series of events today. We're going to call it Space Day, but it's an opportunity to meet and see Space Concordia's multiple divisions, projects that they're working on this year, and there's a series of talks and conversations happening all day. But first, we would like to begin by acknowledging that Concordia University is located on unceded Indigenous lands in Tiohtià:ke, Montreal, and we respect the continued connections with the past, present, and future, and our ongoing relationships with Indigenous and other peoples within the Montreal community. And here at Force Space, we work with our university community to help mobilize knowledge. We co-create daily activities, examining research questions, projects, things happening all across the university. And today we're running this as in a live stream Zoom meeting, and we are live streaming to YouTube. So those of you joining us via Zoom, if you have any comments or questions, just pop them into the chat. We can read them out. Those of you here in the space, your participation is also important. Just raise your hand. We'll run a microphone over to you. Okay, with that, it's very much my pleasure to pass the microphone over to senior fellow, now retired, at Pratt Whitney, Canada, as well as a Concordia graduate, Keppel Bharat. It's great to have you back, Keppel. Good morning.
Thank you. Thank you very much. When I was asked to prepare this speech, I had no clue what I was going to say. But after talking with Shivam, he told me it's Space Day. So my wife says, yeah, you bunch of space cadets, you know not much. But first I'd like to introduce why I've made the topic Driving Your Dreams to Destiny. I was born in Trinidad, which is a very small country in the West Indies, and we were not very rich. As you can see, I have a very small circle here. The town of Claxton Bay, it's actually a fishing village. So, not being very rich, we had fresh fish every day, and we grew all our vegetables and things like this. Now, the World Wide Web was alive even back then, even though it didn't really exist. Because if you went swimming in the ocean, your parents would know about it. So we were not allowed to swim in the ocean. But Trinidad is a small place. As you can see, we are very close to Venezuela. Most people in Trinidad speak Spanish. And in the course of my career, I learned Italian, and I also learned French because I worked here in Longueuil in Quebec. Now, as a kid, I was always into everything. My mother always told me, you like to get into trouble too much times. I was a small kid, but I had big ideas in my head. And that did not go well with the people who taught me in school. It all started in 1963 when my father died. They took me, the kids, I have one brother and two sisters, and they distributed us to the relatives because my mother couldn't afford to keep us and work. So I went to live with my uncle who had a farm. It was just a very small farm. And I was 6 years old, to just coming on 7. And he put me, knowing that I could count and write and read, he put me in charge of bookkeeping. So I was slave labor, if you want to say that, at 7 years old, doing bookkeeping for my uncle and my aunt. I noticed a lot of the times they were throwing away tomatoes. Now, if you look at the tomato stem, you will see there are 6 fingers on the stems. So what I developed, remember I was only 6 coming on 7, when we picked the tomatoes in Trinidad, it would last 5 days. So every day I would pick off 1 leaf, next day another leaf, next day another leaf. So when you had 4, 5 leaves gone, I told my aunt, and this is my first lesson on customer, right, interaction and servicing your clientele. I told my aunt, if someone buys a tomato, give them one of these that has only 1 leaf, because you were going to throw them away in the next couple of days. And she did that. And it worked quite well because that was a customer reward and the people loved it. On the bookkeeping side, I also had to keep track of if you bought something. You remember in Trinidad at that time, we didn't have paychecks. You wouldn't have a check every 2 weeks. You would go to work, you would get paid for that day, and then when you came home, you would settle your accounts with everything that you bought. So I kept track of who bought what, if they paid, if they did not pay. And my aunt was very relieved because I was able to be the bookkeeper and develop some processes. So that's where it all started. Now, when we went back to living as a family again, we had no lights. Everything was done by sunlight. And the family table was the center of affairs. Because what happens is that your mother was there teaching, and all of your siblings would be around you. I would be very quick and finish my homework and my chores, and then I would ask them, "What are you doing?" And they would explain it to me. So at 7 and 8 years old, my sisters, who were much older than I, were showing me how to do arithmetic progressions, geometric progressions, use log tables, and all of these kinds of things. You probably don't know what log tables are because you have everything on the computer, but back then you had books with logarithmic tables. So they showed me all of this stuff. And I learned at a very early age how to do area calculations, volume calculations. And it was very, very interesting because that training goes with you in the future. Now, our classrooms were exactly like this. You would have 50 students in a room. I know in Canada, you have some limit of 22 or 23, I think. But just remember, in Trinidad, we were beaten. And what would happen is the first students in the first row, the teacher would sit here and they would just want to reach over and smack you on the head if you don't know when they ask a question, if you didn't know what the answer was. Now, I was always lazy. I didn't want to do anything. So I figured out at an early age, why do you need to calculate anything and write it down? You have in your head a very wide spectrum. There's a huge computer that resides in your head. So I would do all of the mental calculations and just write the answers down, give it to the teacher to go outside and play. Well, that didn't work because they thought I was cheating because I would go and look to get the answer for somebody and just write it down. And I was taken to the principal's office for being, first of all, rude in class because I told the teacher, no, I was not cheating. So she took me to the principal's office. And then he started writing, because she said it's arithmetic, he only writes down the answers. He started writing something, 2 times 7 or whatever he was writing. And I was reading it in verse and I was telling him the answer as he wrote it. So what did he do? He said to the teacher, this guy is lazy, make sure he does not fail. That was the response. I didn't get beaten. And from then on, I was always moved to the back of the class because if you're pretty smart, the teacher didn't need to reach forward to smack you. So I was moved to the back of the class. So from my early upbringing, what takeaways did we have, right? Each one of us has the potential to develop ourselves to go to a higher level. If you have that potential, you must have the interest in whatever you're doing. Now, my teachers, going back to the previous slide, always told me when your heart is aligned with your mind and your book bag, which I've hidden somewhere in a room back there, you can go places and no one will stop you. So my message to you today is to align your heart with your mind and your book bag. And always be curious. It was very interesting for me to look at all of these models, the rockets, the lunar landing things there, because my interest lies in these things. So high school is now finished. My mother knew I did quite well in the exams. We all sat exams given by the London School of Education. I guess that we call them General Certificate of Education, GCEs, which was issued by London, University of London. I did quite well. but there are not many spaces for students in the West Indies. So my mother decided, you cannot just have a high school diploma, you should go to university. So she applied to come to Canada, right? Now, the Canadian public at that time, you would be allowed, she was a teacher, you'd be allowed to have a job at where they needed teachers. So the first people that responded was Ottawa. So we came to Ottawa. This was in 1973. I had just turned 17. So we arrived in Ottawa. So what do you do when you are in Ottawa? You look to go to school. In that summer, I came in August. I went to the museum, the Aerospace Museum in Ottawa. Now, back then, you didn't have a World Wide Web as you have it today. So I found this company, Pratt & Whitney Canada, and I went through and I looked at what they had in the library. And the library, Pratt & Whitney Canada, it piqued my interest. They had a very small gas turbine engine that delivered 600 horsepower and weighed just over 325 pounds. So I thought, this is fantastic. How can they have so much power from such a little machine? So I went and I did more research in the library, because you didn't have a phone, you have all of these things, to figure out what Pratt & Whitney Canada was all about. So I learned that you had to be an engineer. So I applied to Carleton University to become an engineer. I was refused. Why was I refused? Because up until that time, 1973, we didn't study calculus. They said you have to have grade 13, or you don't have grade 13 here in Quebec, but it's like the finition de cégep, the end of cégep. So the teacher in high school says, if you do your grade 13 here, we will have to learn to teach you 4 years of calculus in 1 year. So I brought with me my calculus book from 1973. So I did 4 years of calculus in 1 year. And then when I applied to go to Carleton again in 1974, they accepted me as a student who met all the requirements. So off I went, Carleton, 1974. Ooh, this one is, I guess it's the bottom of the screen, fellow Isa. The bottom is full no, so you have to read that. So I started in Pratt & Whitney Canada in December of 1978. After 7 months at Chrysler. Chrysler was the first company that offered me a job, so I went to Windsor. And then I started in Pratt & Whitney in 1978. Now, these days, the word DEI is a very, let's call it a word where you have to be careful whom you tell. But to me, Pratt & Whitney Canada represented people who were hired, who were diligent, and they had engineering intuition. So that, to me, is what DEI means. When I started there, we had a mandate. It was a bunch of engineers, we got together, and they told us, we are going to create the commuter market. This was a market of small aircraft that would deliver you from small towns to bigger airports where you can take a big plane to travel around the world. So if you wanted to go from a small town, I would say St. Hubert, you can fly to Dorval, although that's not a very good example. And then you can take a big 777 and fly to Japan if you would like. So we were targeted to develop the commuter market. The people that they hired were all young. We weren't married. We knew nothing. But it was interesting. The team of 12 were from 7 different countries. India, Poland, Pakistan, Trinidad, Tobago, which we are from, and of course, English Canadians and French Canadians. And we learned to understand each other's culture and to understand what each other's strengths were. And if one would not be pulling their weight, we would assist them so that we all moved together as a team. That was me back in 1978. I used to have a big afro, but now I'm not, I don't have much hair left anymore. but that's how I looked in 1978. And we all wore, being in a British company at that time, because most of the guys were English, they all wore ties, white shirts, and dark pants. So things have changed. Now, apparently, they don't wear ties anymore, and they don't wear jackets and shirts anymore. They just wear short shirt, golf shirts and things like this. But what we learned at Pratt & Whitney is you have to be able to go up the mountain. Things are not easy if you don't understand what you're doing. Deming said, if you cannot map your process, you don't know what you're doing. Deming is an expert in quality. So we looked at everything that we had to do. There was a lot of effort required, a lot of politics and infighting. You had to have connections to know who can help you to do things. And you had to understand. You had to understand what you were doing, why you had to do it in this way, and how is the best way to do it. Simon Sinek gave a speech on that. What, where, what, how, and why. If you don't get those three equations solved, you are not going to be as effective as you should be. Because what happens is, if you don't understand why you have to do something, right, you will not understand the reason why it works or why it does not work. In my progress at Pratt & Whitney, I'm going to take a few minutes to explain this. I found out I was lost. So in English, we say compass, and I don't know how you say it in French, but I developed the compass model of how I understood Pratt & Whitney. Let me take a minute to explain this to you. The N in engineering, or it doesn't show up. The N in engineering was for north. South was a service center. East was the engine center. And at that time, we were working in French and English. So Ouest, which is west in English, was opération. So what we did was, you can stand in the middle of that compass and look at any direction and figure out exactly from the problem that you have, if this is the problem that you're studying, where is the weakest link in the chain? Was it something that was improperly serviced in the engine or built in the engine center? Something that was not constructed properly in the operations, or was the engineering wrong? So I use this as my compass, my guide on how I would go forward to solve any issues that arose, right? Very simple model. Unfortunately, it didn't work because the systems issue still persisted. I had failed to understand the full supply chain. Let's just call it the supply chain of a product. I had failed to understand that. So I went back to the drawing board and I modified my model. It was no longer north, south, east, and west. I made up a new acronym called HOMS. Now, let me explain this to you because it's very important. As you launch your jobs, your tasks in the space administration, the space quest, you have to look at the human resources. If you're trying to build a team, you have to make sure you get the right people to build this team who are knowledgeable in what you want them to do, how to do it, and why it has to be done. So that's the human resources. You need them on site. What I had missed was, when we design the engines at Pratt & Whitney and we put them in the aircraft, how are they operated? How are they operated? Because if you don't understand this, when they break, you will not understand why they get broken. I'll give you a story a little bit after. Also, the marketing people will sell everything to the OEMs, the original equipment manufacturers, without understanding the impact on the engineering and the product that they are making. So we'll be very careful if you overmarket yourself. The manufacturing is very difficult. These days, we no longer have operators running mills and doing mechanical things. In fact, right now, most of the companies are working with what we call black cells. Black cells means all the machines are run by robots is black because there's no lights in there. Once you have a three-axis coordinate system, the robot knows exactly what the parts look like, and they will machine, inspect, and deliver you a finished part. So when some people south of here think about or say they were going to repatriate everything back into that country close to us, they are not. I am not too sure they understand what they're talking about, because the robotics today, the robots don't care where they are sitting, where the plant is sitting. All they look for is green power and materials that they get. So we have to be very careful about that. Engineering, you must understand all of the ins and outs of what you're doing and how to calculate everything. If you don't understand how to calculate everything, ask the people who were there before. Learn and find out. You have one mouth, you have two ears, listen a lot, and ask questions to the senior people. Finally, service center. What we had done in the service center is we asked to have dirty engine reviews. What is a dirty engine review? A dirty engine review is after the engines have flown for 1,000 hours, it comes back, they take it apart. We ask them to lay all of the components out on a table without washing them. What that does, it allows you to see the condition of the components as received in dirty condition. So you will understand, is the airflow correct around them? Is it burning? Is it over temperaturing? What happens? Is there carbon formation? It allows you to see many things that you don't see on a drawing board. Well, I say drawing board because that goes back. Now everybody uses CAD screens. What we learned was how to get things done, right? By going from the operations side, including the aircraft, to the service center. I met the pilots that flew the first Gulfstream 600. And I asked him, I says, so how did the engines work? And he gave me a blank look. So I says, well, you flew the aircraft, didn't you? He says, yes, I did. So I said, well, how did the engines perform? And he told me, he says, I don't know. I was confused. And he said, Keppel, let me tell you something. When we have a new aircraft and a new engine, we have an iPad where you have 30, 40 screens of things to check. So they go through, and as they do the cycles on the engine, on the ground, if everything works well, they take that page and they put it to the back. So they don't worry about it anymore. He says, all I can tell you is that every time we push the throttle forward, we got thrust. That's all I can tell you. So I said, they worked well. He says, yes. So I had no input on how the engines performed. Now, they did have data charts that they sent to us, so we could have seen in reality how it performed. So that's what we have learned. Understand what you're doing, how to do it, why you do it, and speak to the people who actually fly or operate the vehicle that you're using. Now, the HUMS model allows you to build a fully functional team. When you design things like that lunar rover on the outside, it's not just one person doing it. You have a team of people that have come together to make it all work. And unfortunately, what happens in the real world is you have some people who don't quite get the image of working as a team, because you have many silos, and these silos are solid lines up to their directors and VPs, but there is no interaction from silo to silo. So what we did at Pratt & Whitney, the project management team, which I was one of the leaders of, we went to each and every silo and figured out exactly how they worked and how they can be integrated in the overall design and manufacturing process. Another thing that you were left to do is you had to go and talk to the customers that flew the aircraft. It was a one-person show. So each program manager you would have, my specialty was the Q400, which is at that time built by de Havilland. You would go and talk about the PW150, And you had to understand each and every issue that occurred on the 150 and what you were doing about it. You didn't have a team of 12 people, it was just one. So you had to be prepared to talk to the end user of that, and also the marketing people that sold it to the OEM, the equipment manufacturer. So that lunar landing module, if it does not work, as a program manager, you should be able to understand and explain everything that does not work on it and things that do work. So that's how we got over this silo issue. The team that we had formed, we asked them to make sure that they were fully cognizant and competent. We needed self-drivers. And this is my daughter's idea, because I was asking her, how do we get something that's self-driving? Why do you need self-drivers? Because you want to set the team on a path, tell them what the actions are, and then walk away so that they will know what they have to do, when they have to deliver it, and communicate with the person downstream. So if you have a process where you have 1, 2, 3, 4, 5 points to deliver, person at point 1 must know at what time person at point 2 wants to have the data that you are working on. Unless you do that, the process becomes very long. So as the program manager, we had to understand each and every milestone of what had to be delivered and when it had to be delivered. It's not as simple as it seems. To be able to do that, you have to understand the full design cycle, manufacturing cycle, from concept to aftermarket. And that takes a long time. When you start to think like this, at a system level, you will understand exactly how the end users feel. Because there was an aircraft that crashed in Toronto, it landed upside down, right? The people were not happy because they did not pay for that. You know, the aircraft came in, I'm not sure if it came in too fast, but for some reason the wing broke off and then it flipped over on its back. No one died, no one died. But it's something that they have to understand. How do you prevent that from happening in the future? It's the same with birds. When you hit birds, the engines are not happy. So you have to understand, how do you design for one bird into the engine? All the rules and regulations are governed by Transport Canada. So when you have a full system integration, understanding, and your team is fully cognizant, you have the process made. Now, to make sure that we always had clean, fresh faces coming in, we developed a 1, 2, 3 system. When I hired someone into my team, they will start off at level 1. They'll be taught everything to get them to be fully self-sufficient. That brings you to level 2. When you get to level 3 is the point at which you can teach a next person coming into the group. Then you go one step further. Level 4, I would kick you off of the team. Why? Because you are fully self-sufficient. Now you can go off into another area and apply that knowledge over there. And to replace that person, a level 1 would come in. People will think, oh, HR would not take this easily. But in fact, they loved it, because it means that your team was fully integrated and your company became a much higher level. We call this the sphere of influence. The sphere of influence starts this small, and as you become more and more knowledgeable, it grows. So you can actually touch different people all over the company. Sphere of influence. Why? Because you want to be able to make everyone the greatest of all times in that specific department. So this is how we created people who were fully knowledgeable and become a GOAT, the greatest of all times. It worked quite well, and they were well reimbursed. When I started at Pratt & Whitney in 1978, I wanted to be a greatest of all time. Normally, at that time, it took 2 to 3 years to go from one grade level to another. The VPs were at level 1, we started at level 8. So normally in 20 or 25 years, you'd get to a senior level. Well, I did not want to wait 25 years. So what I did, I found every specification on everything that I was working on, and I read it and understood it. And what did that do? In 7 years, I was able to go from level 8, where I started, to level 4, which normally took about 12 to 15 years. So I broke the mold in HR. And at the end of my career, I became a senior fellow, which means we set the technical direction that the company was taking. HR didn't like this because people said, well, wait a minute, how come Keppel Bharat did it in 7 years? Why are you telling me I must wait 2 to 3 years now? Well, things have changed. Now, I use this ABBA. My brain is very small. I am not very smart. So to be able to understand things, I have to remember it from stories. This group, you probably don't know them. They were a group from the 70s, and they had a song called Mamma Mia. I found out that you can actually have all of the knowledge in the world in what they call the 4 M's plus 1. The first one, manpower, is actually split into 2 subsets. It's your personal character and your personnel. If you treat the people that work for you quite well, others outside will notice, and they will actually see your group being very functional, cross-functional, and churning together as a group. That builds your personal character. So you have your personnel, that's the people who work for you. You have to build them up. And then the other managers and directors will see what you're doing, and that builds your personnel character. Manpower is the most important thing that you have in your workforce. The second thing is materials. You must understand the materials, the allowables, what you can design for that specific operation. So you have to understand the temperature limitations, the 0.2% yield, all of these things. The third thing is the methods. How do you make something? It has to be documented and understood. The fourth thing, manufacturing. Get the manufacturing guys involved at the design, drafting, drawing boards so that they can give you input on how they manufacture. And the last thing is the money. Everything that you do, you should be in a position where you are always in the black. In the black meaning you should be making money. If you are not making money, something is wrong and your business is not going to last very long. So as you launch into Space Day, all the things that I mentioned to you, you should be going through in your head, how do I do that? How do I get people involved? How do I understand what I'm doing? Do you have a proper definition? Do you have a proper design requirement specification for everything that you are doing? When you have problems, you create fishbone diagrams. I did not put a fishbone diagram here because all of the ones that I've had was from my previous experience and I had no authority to release it. A fishbone diagram is exactly as you call. When you have a fish, you can actually separate the fillets and you see a main structure with legs coming out of it. What we had done at Pratt & Whitney is we would create fishbone diagrams for everything that could possibly go wrong in an engine when it's operating. And we would go and leg by leg, we would say, what can cause this and what can we do to fix it? Then if we were running an engine on endurance, for example, or we're doing some special tests where there's possibility of failure, we rehearsed with the test engineering team what could possibly go wrong. So then when it does go wrong, there is no panic. There is no panic. They will understand this goes wrong. This is what we do to fix it. And then I would be called. Somebody last year came out with this acronym called FAFO, F around and find out. Well, we had done this a long time ago. This is what happens when you F around and find out without understanding the outcome of what you're doing. If you were to go back to my previous chart, we would actually simulate what would happen if you were to go too much on one side with this boat. So then you set limitations. And then once you understand the parameters that control the operation of the thing you're designing, you can say, okay, let's go a little bit outside and see what happens to the point where you become close to tipping, but don't go over. In fact, you go to the edge of the cliff and then you back up. And you ask yourself the question, how can I move the edge of that cliff further away? That's how you have continuous improvement. That's how you get things to work even better. So this person that came up with this FAFO, they just learned what engineers have been doing a long time ago, right? You have to push the envelopes of what you are operating. This is a chart that tells you it's the most complex system that you have. The engines, you're coming in, the engines are at idle because you want the plane to descend. You are in contact with ground control, with air traffic control. You're also in contact with other aircraft because nobody can be on the runway. So this, for me, represents a full system level process. The pilots in that aircraft understand exactly what they are doing. The air traffic controllers know what they're doing. The ground traffic controllers are predicting where they're going to be. And the other aircraft around know what's happening with them. So this is the full systems level thinking that's required, even in space. As you go up through the atmosphere, you must understand where the other satellites are. There's a whole bunch of other things going on around there, flying around. And this last slide tells you leaders will always change. So when you get a new leader, you must understand what they want to do, why they want to do it, and how are they going about to do it. They must have a roadmap. This is the end of my presentation. So I wanted to know if you have any questions. And I'm pretty well on time. No questions?
If anyone in the audience has a question, please feel free to raise your hand and I'll get this microphone to you. Any questions at all? Does anyone online have any questions? Please feel free to pop those into the chat now.
I couldn't have been that clear. Oh, are you good? You understand everything? So if I ask you a question, you should be able to answer me, right? No, I won't put you on the spot. I won't put you. Well, thank you. Is there any online questions? No?
I'm not seeing any questions online, Keppel, but I do think that what we'll do is we'll close up the live stream and the Zoom, and then if anyone does have questions, they should come and talk to you kind of directly.
Personally, so that you're not on public record.
Yeah.
But I will tell you things. All right. Well, thank you very much for your time. And I wish you guys, I see all of this stuff out there. It's very interesting to me. Very interesting. But I retired 6 years ago. I'm not dead. I'm not dead. The brain still works. But I will go and have a look out there. Thank you very much for your time.
Thank you, Keppel. Thank you, everyone. Thanks for joining us. Woo. And also stick around. We have a few more events happening today, but we're going to close up the Zoom and the live stream now. But you can join us back at 12:15 for utilization of space to better life on Earth with Gennady Krupnik. That's at 12:15.